Hi apes, today we're taking a look at Unit 8 Part 1, which is going to focus on water pollution. Unit 8 is going to take us both through water and land-based pollution, but for the first couple of recordings we're only going to focus on water pollution. So to start off with, we have both point and non-point source pollutants for both land and water-based pollution. Now you might remember this term from air pollution, that point sources are literally something you can point to. So down here on the bottom of the screen you can see that there is a pipe that is discharging into the river. So that would be good point source examples of pollution. Now for water pollution, most of our non-point source we consider to be runoff. So you might have runoff from agricultural lands, runoff from urban or rural areas, and also from suburban areas. So in summary, a point source pollution tends to be a pipe that is discharging into a river, whereas non-point source pollution for water is runoff. Now, when we have our human impact on both water and land pollution, the biggest concern here is that a lot of the pollutants that we're putting into the environment are impacting animals and plants in our environment. And so the pollution will often push them outside of their range of tolerance for species. If you remember from earlier in the year, a lot of species will have a range of tolerance of different conditions. For example, something like pH. Now, if there's an acidic addition to an environment that might push the pH too low, and an animal might not be able to go through their metabolism properly, or you might see changes in reproduction. Another issue is that heavy metals can be incredibly toxic, and heavy metals might be able to enter our surface or groundwater surfaces, making it so that we can't drink the groundwater, making it so that living things can't drink the groundwater or surface water. Now, a specific example of this is from the burning of fossil fuels with coal. The burning of coal will release mercury into our atmosphere. Now, mercury can be converted to methylmercury by bacteria, and mercury acts as a neurotoxin. That means it affects the nervous system, and that can impact both humans and animals. And mercury is something that can biomagnify up the food chain. Now, our water quality indicators, some of the things that we take a look at to see how good our water quality is one of them that we look at is indicator species. Now, for indicator species here, what we're taking a look at is animals or plants that their presence or absence will suggest a certain level of water quality. So, for instance, if you have fecal coliform are found in the intestines of mammals. So they are bacteria that are found in your intestines. And so if we find fecal bacteria or fecal coliform in our waterways, what that means is something that was once in a mammal's intestines is now in your water, which means there is poo in your water. Another thing that we can take a look at is whether or not the species that are there are known to be sensitive or tolerant to pollution levels. So there are things like leeches that are very tolerant to water quality. They can live in very low oxygen and relatively high pollutants. So if you see nothing but a lot of leeches, then that's a sign that that water quality is not good. But if you find things like mayflies or water pennies, those tend to be only found in water that is higher quality. And so if you find a lot of sensitive critters in your water, then that is a good sign that the water quality is good. Now, you can also find leeches in the same places you find sensitive, but because those sensitive critters can live there, that means that that water quality tends to be on the higher side. Another thing that we take a look at when we're looking at water quality indicators are nutrients. Specifically, some of the most common ones that we look at are nitrogen and phosphorus. Now, you might remember that these come most often from fertilizers, both in agricultural areas as well as in suburban areas from people putting too much fertilizer on their lawns. This often becomes part of runoff. So this will if there's excess fertilizer, when it rains, it'll pick up those nutrients and run off into our surface waters. Now, another thing that often is in runoff as well is sediment, and that sediment will become part of runoff and make its way into our surface waters, and that increases turbidity. This is the cloudiness of water. Now, this is a problem because if the water is too cloudy, then what that means is that water won't be able to penetrate all the way through, and it will prevent photosynthesis from going on. So the turbidity is caused by sediment, and that can lower our photosynthesis, which can lower the amount of dissolved oxygen in the water. Now, pH is another indicator. Most critters like to have a pH right around neutral of 7, but a lot of times we can have a pretty healthy range of about 6.8. But if you get too far beyond that, it might become too acidic or too basic for most living things. Now, another thing we take a look at is BOD and DO. The BOD is the biological or biochemical. Sometimes it varies depending on what you're actually looking at. Oxygen demand. So what this means is how much oxygen is needed in order to support life, or to support life and go through chemical reactions that are going on in the water. And the DO is the direct measure of how much dissolved oxygen there is. And this is very key because critters will need to have oxygen. And unlike us, who can breathe it from the air, they need to use their gills to filter it from the water. So here, dissolved oxygen is going to be a really key indicator of whether or not you have the ability to support life. Now, BOD and DO tend to have an inverse relationship. So here, what we see is a river that is flowing down towards the bottom of the screen. And we have an input of waste right here at the mid-level of our river. So in a healthy river, what you like to see is a low BOD and a high DO. So what this means is there's enough oxygen to support life in there. Now, when we have pollution occur, what happens is that a lot of bacteria will have to come in and start to decompose this waste, and that drives the BOD up. So when the BOD increases, it's because there's a lot of need for it. Decomposition is a heavy oxygen dependent activity, and so that's going to increase the need for oxygen, and that's going to use up the existing oxygen. So you see this swapping of roles, that now I have a low DO and a high BOD, and that's a signal that there's some type of pollution in the water. But because this is a flowing river and it will be able to continue to refresh, the river will recover and the BOD will continue to drop back down to its original, and the DO will continue to increase. So this is a pattern that we tend to see with pollution. Now, water pollution in general, just some general characteristics. Remember, it can be point or non-point. So again, here's a good example of a point source because of that pipe. And non-point tends to be runoff. Now, sediment is one of our biggest non-point sources of pollution, and this leads to that turbidity in our water. And you can see that in the picture down below. This is our Potomac River that is filled with sediment. That's one of the highest pollutants in our Potomac River. Another thing we take a look for is infectious agents like bacteria. Fecal coliform, remember, were that indicator that there was poo in your water. And while fecal coliform themselves may not be infectious, what they do signify is that E. coli might be present because those are often found in your intestines as well. Organic waste is possible. By here, I pretty much mean like a poo can run off into our waters or the living things in that water. Chemicals from runoff or point sources. So these can be point or non-point. Industrial chemicals, some factories are able, they're permitted to be able to pollute a certain amount into their waterways. Pesticides, this mostly would come from runoff. Nutrients like our nitrogen and phosphorus. The reason why we're concerned about this is that that addition of nutrients, just like on land, will cause plants to grow. They'll cause an algae bloom in our waterways. We talked about heavy metals. These might come from airborne, like mercury being deposited from the burning of coal, or runoff. One big source of heavy metals might be your brakes. They'll release metals onto the roads and they'll become part of runoff. Thermal pollution, this most often comes from electricity production or from factories. Remember that thermal pollution is just warm water. And the reason why we're concerned about that is because it does change the conditions of the water. If the water's too warm, it might actually lower the amount of dissolved oxygen that water can hold. And then we'll talk about solid waste as well, and this mostly is litter, and we will focus in here on things like plastics in our water. So here's just a general summary of some of our water pollution concerns that we have. Now what we have here, this is called an oxygen sag curve. So this is what you typically might see when you have an input of some type of pollution, both in the amount of oxygen that you see as well as the indicator species or the characteristic populations that you might see. So in a clean zone, we want to have a high dissolved oxygen and a lower BOD, and that means there's plenty of oxygen present. You would see things like trout and perch and mayflies and stoneflies and nice healthy biodiversity. Now, if we have some type of input of sewage or pollution into our water, that's going to cause the need for a lot of decomposition. So my BOD is going to spike very high, and that's going to drop my dissolved oxygen very low because I'm going to continue to use up oxygen in that decomposition phase. So you see an area of the river that's going to have our indicator species that are very, very tolerant. Things like sludge worms, midges, mosquito larvae, not a lot of fish because the fish need the oxygen to survive. But then because there's flow, you are going to see where you have a recovery zone where some of your more tolerant fish are going to come back. And then at the very end, you will see a complete recovery. So in a river with flowing water, you are going to be able to see a recovery back to a healthy level of oxygen. Now I want to end here with talking about eutrophication. So eutrophication is a very important concept that takes a look at the impact of nutrients on our waterways. So eutrophication technically is the addition of nutrients that leads to a drop in dissolved oxygen in our waters. But I like to think of it more of a process. So a series of steps. That the first thing that occurs is that nutrients are put into your system. Most often, this is going to come from runoff of fertilizers. So you have nutrients that get into your system, and just like nutrients particularly are nitrogen and phosphorus, they are going to feed the plants in the water. So they're going to be able to cause an algae bloom. Now, an algae bloom is a problem for a couple of reasons. One, it forms that green scum at the top, so that might block light. And that algae will quickly die, and that death will require decomposition. So bacteria will come in to decompose our bacteria, or to decompose that dead algae. That causes the BOD to increase because of that decomposition process, and that drives our DO low. And then the end result is you have your fish die. We have what's called a fish kill. And sometimes it will create dead zones. And what this means is the water might become completely anoxic, which means that it is without oxygen because the decomposition process used all of that up. So I like to think of eutrophication as a series of steps. Starts with nutrients coming in, and that leads to the algae bloom. That algae quickly dies, needs to be decomposed, which drives our BOD up and our DO decreases. And the end result is that our fish die because of the lack of oxygen or a dead zone. You'll be able to practice a little bit with this in class as well. Okay. Now, one thing that you're going to be working on is some guided notes on a variety of different types of pollution. So I want to just introduce this to you so you can have a visual, but you'll be filling in some of the holes here about these different types of waste. So one that we'll take a look at is human waste. We here in the United States do treat our waste at wastewater treatment plants, but that is not the same in every country. Sometimes human waste goes directly into our waterways. Animal waste, we do have a problem with this. These are feedlots from our CAFOs, so these are waste lagoons from our animals. Waterborne diseases, so you're going to be taking a look at things in particular like cholera and dysentery that are spread from drinking water. You're going to be taking a look at heavy metals, in particular things like mercury and arsenic and how they get into our waters and how that causes human and health problems and how they might biomagnify up the food chain. You'll be taking a look at acid mine drainage, going back to our coal mining and seeing how the coal tailings might lead to water pollution. You'll also be taking a look at pesticides, pharmaceuticals, hormones that might be left over in our wastewater, as well as industrial compounds. So pesticides, this is traditionally runoff from agriculture. Pharmaceuticals and hormones, they are typically from wastewater treatment. They get flushed down our toilets and not taken out by our wastewater treatment plants. And then finally, just to end this out, I want to just address the two laws that are tied to water. One is the Clean Water Act, and what this does is this takes a look at our surface waters, making sure that our surface waters are clean. And then the Safe Drinking Water Act, what this one takes a look at is what are the regulations for pollutant levels, salt levels, bacterial levels in our drinking water. So next time, what we'll be taking a look at is a little bit more specific pollution to our oceans.